All right, so today I want to go over how I'm orchestrating AI agent prototypes by using Hex, Dagster, and LangChain. Um, just a quick overview of what I'm putting together. So I have my Dagster orchestrator, which is materializing assets. One of those assets is a AI agent. So essentially, what's happening is I have this platform which mines online conversations about climate change, and I want this agent asset to go over the conversation's content, enhance the information that is available by performing additional research. And writing up a brief about what the conversation is about. So by using LangChain, interacting with an OpenAI um, LLM, and essentially what I'm doing is that I have the conversation that is passed to the agent. The first thing that it does is that it assesses whether it has enough information to write a brief. If it doesn't, then it starts performing research tasks. It leverages investigative tools that I've provided to it, and it writes back all of its findings to a notepad manager, which he then uses to perform a further assessment of whether it has enough information to write a brief. So it cycles through that, and then eventually, when it assesses that it has enough information, then it will write a brief, which will be written back to the assets materialization. And then if you're familiar with Dagster, then you know that afterwards I can have downstream assets that will consume the output of those upstream assets. So that is the use case here. The AI agent has been written in the prototype itself is in Hex. Essentially what is happening is that it's waiting for a conversation ID and the in that case conversation markdown, but it's really all of the back and forth that has been happening on a social media platform around that conversation. And then here we have the actual conversation that occurred. So the AI agent, what it will do is we have that state that we first defined. In that state, what we're keeping track of is really all of the findings that the agent performed, like all the research tasks that it performed and the findings that it got from those research tasks. And also the assessment of whether it thinks that it has enough information to write the brief. We have the investigative tools. So in our case, we're just using DuckDuckGo for our search engine, and then Wikipedia. Those are the LLM chains that we'll be using within that agent. So for example, this one is performing an assessment of whether we have enough information to write a brief. This one will make a decision as to which tool to use to perform research tasks. And this one will write down a summary of its findings. And finally, we have this one, which is doing the final brief that will be outputting at the end. So if you're familiar with LangGraph, then those concepts will be familiar. So we have nodes. So those are really like the steps that are taken by the agent. So we have that assessment node, which will be leveraging the LLM chain we just shown above. We have a research node. And then we have that brief writing node. And finally, we have the edges. So those are really the path between the nodes. But again, I won't go really into too much details about that. You should really look into the LangGraph. There's actually like a good LangGraph Academy that is really useful if you're new to that. So yeah, I highly recommend it. So we have those conditional edge functions. where the agent will kind of decide which path to take based on, for example, in that case, the assessment. So if it decided that so if it assessed that it had enough information to write a brief, then it would go to write that brief. If not, it would continue performing research. And I have another one, another conditional edge function to limit the number of research cycles. Else, like it could just go on and on and on. So this is the actual agent that is being put together, again, like using LangGraph. So I'm adding all my nodes, adding all of the edges, so really the paths that the agent can take, and as well as the conditional edge, and we can have a small display here of how it would perform the enrichment of those conversations. So if I invoke that agent, this is just a simple invocation. We can see the path that it takes, and then we'll see the output in another at a later point. All right, so how I'm putting all of that together in Dagster. So I'm first leveraging the Dagster Hex library, and there's already a Hex resource class that is available. I'm overriding that class just because I wanted to make it configurable, but essentially, like, I'm just using the same run and poll function that is available through that class. So this is just my own class definition of that resource, and you can see how I'm initializing my own instance of the X resource. So I'm just passing the API key here, and this is an asset that is doing the interaction with the Hex notebook. So if you're familiar with Dagster, you'll kind of see how that works. But essentially here, I just am defining the Dagster and the decorator here, the asset and the decorator. So those would be all of the upstream asset that it relies on. Then I have my partitioning definition, the compute kind. In this case, it's hex. But really, where the magic happens is here. So I'm using my Hex client, and I'm performing a run and poll on this project ID. So this is the ID of the project that I'm using in Hex. If you remember, I needed to pass some inputs to the notebook. So I have my conversation ID, and I have the actual conversation data that I package into a markdown string. And that's it. So I'm invoking my Hex project, running that, and once it completes, then I'm just saving the output to a type dictionary that I will be saving as metadata in Dagster. But the XAPI, the main things that it will return are the run ID, the run URL, and the trace ID. And I'll show you what that looks like here. But first off, like this is the lineage of my project at the moment. So I have some assets that are being materialized prior to going to the prototype. So here I'm just grabbing all of the articles around climate change from the New York Times, and then all the conversations that reference those articles on the X platform. And then here in prototype, this is where I'm invoking my AI agent. So I'm grabbing completed conversations, and then I'm running the agent on top of those conversations so that it can output a brief. And we can see an example of a run. So this is just the asset definition with its metadata, and this is an example of a run. So really it just ran that simple asset here, but we can see here that when we invoke the project, then it pulls the status of that run. I don't know exactly, like every 5 seconds or something like that. So it keeps running until then at some point it completes. All right, and then we can see the metadata that is being saved in Dagster for that specific run. So we have the run URL, and then the trace ID, the run ID. We have where the output of that run is saved to. So if we open that run URL, then we can see that this is the run that was specific to that call, and I can see the output at the end, which I just packaged into a markdown string. But essentially, I have the information in regards to if it assessed that it had enough information to write the brief. In that case, it was false just because it reached the research cycles of 3. It has all of the research tasks that it performed, and we can see that it used DuckDuckGo in some cases, and it used Wikipedia in other cases. And at the end, then we have the brief that was produced by the agent. Now, the X notebook at the end, it uses the writeback cell to save the output of that to BigQuery. Now, this is the metadata that has been saved by Dagster. So we have the conversation ID, the run ID, the run URL, the trace ID, as we saw in the metadata. But if we look also here, and we can see that this is what the hex project saved with the writeback cell. So for each conversation, it will have the information that what was displayed on the X notebook. So all of the research findings and the brief as well has been saved in BigQuery. Now, the final thing that I wanted to show is with Langsmith. So I'm using Langsmith for my prototypes just to keep track of how they're performing. So for each request with the agent, I have a bunch of information. So for example, I have the number of tokens that were used, the cost associated to that agent run, but I can also see like the full sequence that it took. So I can see that it started with an assessment of whether it had enough information to do to write the brief, and it didn't. So it performed like some research based on the task that it generated, the research task that it generated in the previous step. So it used Wikipedia, and then it ran again. And just keeps going on and on and on. Another assessment, another bunch of research, and all the way towards like writing the brief here. So really, if I want to go really deep into the actual call, the agent call, into what really happened under the hood, then Langsmith is really useful to get all of that information.